Hi, I'm Rodney Sharp, owner and president of SharpGrade International. Today we'd like to talk about cross-coupling and what it means for precision grading. Now you'll hear us talk about cross-coupling, and cross-coupling is when the movement of one side of the blade influences the opposite side of the blade. Now sharp grades all come standard with QuadRod linkage, which do not have a centre pivot, and so cross-coupling is normally caused when you have a centre pivot. So all centre pivots have the worst type of cross-coupling possible, where one side, the movement of one side of the blade is directly influenced by the same amount on the opposite side. So what I've done today is I've set up a SharpGrade with an imaginary blade with a centre pivot in it that mimics what a centre pivot blade would do when it's moved. And I've mounted one side of the blade to our side, which will be moving, and then the other side is free to move. So when you have a centre pivot blade, whenever you do a cross fall, you have to rise or lower the whole entire blade to get them back into line, because as soon as you alter one side, the opposite side is altered the same. So what we're going to do is demonstrate that here. So here we have our SharpGrade set up with our imaginary centre pivot. So here's the centre pivot, and here's our blade connected to this side. And you can see the arrow, the movement that is occurring in a centre pivot blade. So a centre pivot blade is the worst combination you can ever have. There is nothing smart about a centre pivot. And this is what you find on 6-way blades and most box blades. If your blade has a pivot in the centre, then it suffers from this problem, pure and simple. Whereas you notice the QuadRod linkage is keeping the opposite side at the same height relative to the ground, whereas the other side can move through its entire stroke without affecting it. And that just allows us to grade quicker and more accurately, because we only have to control one side at a time. So that's the secret of accurate grading, is the QuadRod linkage, and that's a patented system that only SharpGrades have. Let's explore a centre pivot blade a little more. Here's our blade with our centre pivot in it, 96-inch blade, and so that's 48 inches to here. And let's put an 8-inch lever on it, because you have to have some cylinder somewhere to make it work. Okay, and we'll call that 8 inches. Let's be generous. Okay, so 8 goes into 48 6 times. So this cylinder, the movement here is multiplied 6 times on this end. So we've got a 6-to-1 ratio. Okay, and we want to grade within 1/8 of an inch, which is 0.125. Okay, now we know that we have to have clearance in our bushes to be able to fit everything together quickly and easily. So let's be conservative, and we'll give it 10 thou in each of these. So we've got a total of 30 thou of movement. So we multiply that out and we get 0.18 of movement, which is greater than the accuracy that we were aiming for. And this is before we add anything else into it. But what else do we need to add into it? Well, when we start looking at these ratios, we need to start looking at the compressibility of oil and things like that. Okay, as a rule of thumb, oil compresses about 0.5% for every 1,000 psi. So let's say we put 1,000 pounds of load on here. That's 6-to-1, we get 6,000 pounds of load on our cylinder. So let's say a standard cylinder that's used is a 2.5 inch by 1.25 inch. That will give us an area in here of about 3.7 inches. Okay, so divided that by that, you're around 2,000 psi. Okay, so if you get 0.5% per 1,000 psi, that is 1%. And if we're talking about a stroke of 8 inches of stroke, so that is 0.08 inches. So we add that up and we get 0.26 inches of movement. So you can see very quickly that a centre pivot blade with standard manufacturing tolerances, suddenly you are talking about double the intended accuracy before you even pass go. This is only with 1,000 psi on it. So the problem with it is because the tilt cylinder is mounted on a very short arm, this ratio becomes very high, and so any minuscule movement here is translated into a large movement here because of this 48-inch multiplication factor. So that's a real high problem. So just remember that 2,000 psi and that 0.26 inches, which is basically 1/4 inch of movement before you even pass go. So how does that stack up against a QuadRod linkage? Here's our blade with a QuadRod linkage in it. And remember, we've got our linkages and we've got our cylinders. Now, we said this was 96 inches and we put our cylinders 72 inches apart. So that's 36 and 36. So, once again, when we push on this side here at 1,000 pounds of load, which is not a lot when you're grading, because we don't have a centre pivot, we never calculate from there, we calculate from this point here. So the calculation is that plus that, which is 72 over 36 plus 48 inches, because that's this dimension here, which is 84, which is 1.16. Okay, so if we said 1.2, okay, so this cylinder sees 1.2 times this load. So 1,000 pounds, that sees 1,200 pounds of load. Okay, and we run a 3-inch cylinder. That amounts to around, so a 3-inch cylinder in round figures has got about 7 square inches of area. So you're under 200 psi versus our centre pivot that had 2,000 psi. So at 200 psi, it's 0.5% multiplied by 0.2. So it's not even worth factoring in the compressibility of the oil. So you can see why a QuadRod linkage is so much more rigid. It's because you shift the centre point from this point out to here. And not only does it reduce the load on this, and it stops that point from virtually moving, so you have zero cross coupling, but you reduce all of the load in the system. And that's the secret to it. And when you think about the 1,200 pounds of force, and we've got a linkage that's a ball end which is rated to 17,600 pounds, and we're putting 1,200 pounds on it, versus our centre pivot blade that had a multiplication factor of 6. So we had 6,000 pounds of load onto the tilt cylinder, and we've got 1,200. So Basically, a centre pivot blade induces 5 times more load into the cylinder than we do. But not only that, it has to be 6 times more accurate in its movement between what we do to what they do, because theirs is in here and ours is out here. And so not only does the QuadRod linkage reduce the load, it also reduces the ratio. So your cylinder is virtually over the top of your sensor. So you can see why a centre pivot blade is the worst possible combination you could ever have. There's nothing smart about it at all. If there was a design that you could make that it's the worst possible, it would be a centre pivot. So if you want accuracy and speed, you don't use a centre pivot. So you can visit us on www.sharpgrade.com for more information, and thank you for your time.